Good morning, everyone. This lecture is the last lecture of the Excel part of the course, and we will start Microsoft Access from the next week. In this lecture, you will learn different analysis tools in Excel. We will talk about goal-seek and solver tools that can be used to identify an input value and optimize results. You will also learn how to use Scenario Manager, create one variable and two variable data tables to try out different input values for formulas. And finally, forecast sheet feature that is used to make prediction on datasets will be explained. Let's start by goal-seek tool, which is the easiest tool in the analysis tools category. Goal-seek is a method for finding solutions to problems by working backwards from the end result to determine the input to produce that result. In other words, if you know the result that you want from a formula, but you're not sure what input value the formula needs to get that result, use goal-seek feature. Look at this example. This table indicates that if you sell 100 items at $5 each minus 10% commission, you will make $450. The question is, how many items should you sell to make a revenue of $1,000? Let's see how to find the answer with goal-seek. As the first step, we should go to the Data tab, click the What If Analysis button, and select goal-seek. Goal-seek dialog box will open. In Set Cell, type the reference to the cell containing the formula. Since we want to set the revenue cell, we type B5. In ToValue, type the value that you want to achieve. It's 1000 in this example. And finally, in By Changing Cell, type the cell name that you want to adjust its value. So type B3. By clicking OK, the goal-seek status dialog box will appear and lets you know if a solution has been found. If it succeeded, the value in the changing cell will be replaced with a new one. In this example, goal-seek has found that 223 items need to be sold to achieve a revenue of $1,000. Watch goal-seek demos in the next two slides.
This is the spreadsheet that I've created. It's called Morgan's Paint, and basically I'm going to be looking at my different types of paint, which are right over here in column A, and these are the different colors of paint, and this is the revenue sources. I put in my current revenue as well as my goal revenue. Alright, well, let's say we're looking at these different paint sources and we see, alright, well, we want to make $300,000 this year. Alright, well, if I want to make $300,000, one or more of these numbers will have to change. So let's say that I'm looking through my paint and I say, hey, you know what? I think we could sell more red paint. Okay, so I take a look at my red paint and I say, how much do I need to increase my sales in red paint in order to make this number 300,000? Well, we could do that by using goal seek, and that's basically what if analysis in Microsoft Excel. So let's go ahead and do that. So the first thing that you have to do is you have to select the cell that you want to be changed. All right, so this cell is going to change to 300,000 because that's our new goal. Again, you select the cell that contains the goal. Then what I do is I go up here to the Data tab, which is right up here, the Data tab, and I click on that. And then I go over here to the Forecast group, and there's a button right here called What If Analysis. Try out various values for the formulas in your sheet using Scenario Manager, Goal Seek, and Data Tables. Right now we're going to click on that and use Goal Seek. When you click Goal Seek, it's going to open up a Goal Seek dialog box, and you'll see right here it says Set Cell C10. That's because this is the cell that I pre-selected as the cell that is going to be my goal. Alright, well, I want that cell to change to, again, my goal was 300,000. 300,000. Alright, so now I can decide which cell I want to change. So I first click right here where it says By Changing Cell, and again, I said I was going to sell more red paint in order to make that happen. So I click right here on the cell for red paint. It says C5 as an absolute, and I say, alright, that's perfect right there, and then I click OK. Now check out what happens now. I click OK, and now what it says is goal seeking with cell C10 found a solution. Target value, 300,000. current value 300,000. So this right here is 300,000 now, and this is now 83,000. So I click OK, and now I know that I have to sell $83,000 worth of red paint in order to bring my goal up to 300,000. So again, I'll do a Control Z so that you can see before. Before it looked like this, and this was 55,000 would bring me to 272. After I ran the goal seek, you can see it jumped up to 83,000 to again hit our goal of 300,000 in total revenue.
Say I'm taking a class in school and I'm not doing very well so far. Luckily, if I get a high enough grade on the final exam, there's a chance I may be able to pass the class. The question is, what grade do I need to get on the exam to raise my average to at least a 70? We can find out using a feature called What If Analysis, which allows you to fill in missing information based on the data you already have. Right now, all I know are the grades I got on the first 4 assignments: 58, 70, 72, and 60. Before we do our analysis, we need to figure out my current average by adding a formula or function in this cell. In this case, each assignment is weighted equally, so we can calculate the number we need using the average function. To get the most out of What If Analysis, you do need to be fairly comfortable with formulas and functions. Luckily, this one is pretty simple. We'll just type an equals sign, and then average. Next, we need to select all the cells, even the empty cell for the final exam grade. If we don't, it won't calculate the average for all 5 assignments. Looks like we're done, so I'm just going to press Enter, and now we can see my current average. Unfortunately, it's not high enough, but we knew that was going to happen. Now we can move on to the next step, using a feature called Goal Seek to figure out what we need on the final exam. Goal Seek is a type of what-if analysis that basically lets you work backwards in order to find a missing value. It starts with the result you want, then it calculates whatever input is needed to get you there. To begin, select the cell that contains your formula or function, in our case, B7. Then go to the Data tab and click the What If Analysis command. There are actually several different types of What If Analysis, including Scenario Manager and Data Table. But in this case, we're going to use Goal Seek. A dialog box will appear where you can set the parameters for the information you need. In our example, we want to set cell B7, that's our selected cell, to a value of 70 by changing the cell that contains our missing value, and that's going to be B6. When you're done, click OK, and Goal Seek will take a minute to see if it can find a solution. Based on the message here, it looks like we were successful. So we're going to click OK, and now we can see the result we were looking for in the final exam cell. So I guess I need to make a 90 on the exam in order to pass the class. It's going to be tough, but I think I can do it. At least now I know, thanks to the work we did with What If Analysis. It might take some practice to get the hang of the feature on your own, but it's a great way to figure out unknown values in your worksheet.
As I explained, with the use of Goal Seek tool, we can find values that can be used to determine an outcome. When you need more complex scenario and you need to work with multiple variables, Solver tool can help you. Solver is used to search for the best or optimum solution to a problem by manipulating the values for several variables within restrictions that you impose. You can use Solver to create optimization models to find the highest, lowest, or exact value for one particular result by adjusting values for selected variables. In other words, Solver can be used to find a projection or a solution to your problem using a group of cells and a formula cell. Also, Solver enables us to define some constraints for the cell values that are used to calculate the target cell. It can limit the numeric range that they can be changed to. Please consider that Solver is an add-in and it's not a pre-existing tool in Data tab. Add-in is a program that can be added to Excel to provide enhanced functionality. In order to add Solver, go to the Options from the File tab. From the Options window, click Add-ins. Then select Excel Add-ins from Manage and click Go to open Add-ins dialog box. Finally, click Solver Add-in and click OK. By adding Solver, it will appear to the Analyze group on the Data tab. In order to use Solver, it requires three parameters. These parameters are objective cell, changing cells, and constraints. The objective cell is a cell containing a formula that represents the objective or goal. The objective can be to maximize, minimize, or achieve some target value. Variable cells are cells that contain variable data that can be changed to achieve the objective. And constraints are conditions that must be met. They are restrictions or limits of the possible solutions to a problem. Supposing you are the owner of a beauty salon and you're planning on providing a new service to your clients. For this purpose, you need to buy a new equipment that costs $40,000 and should be paid by installment within 12 months. Based on this explanation, you want to calculate the minimal cost per service that will let you pay for the new equipment within the specified time frame if you have 50 clients per month. As the first step, open Solver by going to the Data tab and clicking the Solver button. In this example, the objective cell is B7, which calculates the payment duration using a formula. Since we should repay in 12 months, select value of and type 12. As I said, the number of clients per month should be less than or equal to 50, and cost per service should be calculated by Solver. Therefore, in by changing cell, we type B4 and B5. Now we should add the constraints by clicking the Add button. We need to define two constraints here. The first one is the cost of the equipment that should be equal to 40,000, and the other one is the number of clients per month that should be equal or less than 50. Therefore, for the first constraint, we type B3 equal to 40,000, and for the second constraint, we type B4 less than or equal to 50. As the last step, we should select the algorithm that Solver should use to do the calculations. For this purpose, we should click Select the Solving Method and select an appropriate algorithm based on the problem that we want to solve. Solver provides three algorithms, including GRG Nonlinear, Simplex LP, and Evolutionary. GRG Nonlinear is the default algorithm of Solver that is used for problems that are smooth nonlinear. It means the problems in which at least one of the constraints is a smooth nonlinear function of the decision variables. For the beauty salon example, this algorithm will be used. Simplex LP algorithm is used for solving so-called linear programming and mathematical problems, and evolutionary algorithm is used for non-smooth problems, which are the most difficult type of optimization problems to solve. While GRG and Simplex algorithms are used for linear and smooth nonlinear problems, the evolutionary algorithm can be used for any Excel formulas or function, even when they are not linear or smooth nonlinear. Functions such as if and VLOOKUP fall in this category. After you've configured all the parameters, click the Solve button and let Solver find the optimal solution for your problem. When Solver has finished processing, it will display the Solver result dialog window where you should select Keep the Solver solution and click OK. As you can see, Solver shows $66.67 in cell B5, which is the minimal cost per service that will let you pay for the new equipment in 12 months if you have 50 clients per month. If you want to get more details about the solved problem, select the desired report from the reports box and click OK to see the report. The report will be created on a new worksheet. The demo in the next slide gives another example as how to use Solver.
So what I've got here is I have a basic mark breakdown. So we have the 3 marks that make up the final marks for the student. He's already achieved only 75% on his assignments, and he has yet to write his midterm and his final, but he needs to get 90% to get honors in this course. So what we're going to figure out what he needs to do to get this. We are going to go click the solver button here. And so we've already selected the total at the end calculation here. And so what we have now, we would like to change this value to a value. It gives you to maximum, to minimum, or to a value of. So I'm going to select to a value of, and I want 90. Okay, now the next is it's asking you by changing which variables. So we click on the red arrow here, and we select the midterm and the final mark here. And now we click the red arrow again. Okay, now we need to add some constraints here. The highest possible mark that he could get on either of these is 100%. So let's add some constraints here. And so what we're going to do is we're going to select the value, or the cell where the value goes, and as you can see, it's less than or equal to. Now you have from the drop down list, you have other options there of what it can possibly be, but this is what we need. So the most it could possibly be is 100, and then we're going to click add to add it to constraints, and then we're going to click the other cell here, the final, and the same thing, the most it could possibly be is 100. Okay, and so now we say okay. And there it's all ready for you. So now let's click on the solve button here. So let's drag this away. So for this student to get 90 on his final, as a final mark, he needs to get 91 and 100. They put the final value to the highest because the final is worth 40%, so it's more important for him to get the higher mark on the final. And 91.6 is all he needs in the midterm. So we have options here with the dialog button. You can keep the solved solution, restore the original values. Okay, so we're going to keep this, but now what we would like to do is we would like to run a report. So let's select answers and say okay. And now we have our answer report here, and as you can see, it has broken down all the information that is determined for you. So this is how you use the solver.
Data table is one of the analysis tools in Excel that allows you to try out different input values for formulas and see how changes in those values affect the formula's output. Data tables are especially useful when a formula depends on several values and you would like to experiment with different combinations of inputs and compare the results. Before talking about one variable data table, you should know 2 terminologies: variable and substitution. Variable is a value that we change it to see how it affects our values, and substitution is a value that replaces the original value of a variable. Suppose you're considering depositing your saving in a bank which pays 5% interest monthly. You want to see how much you can get after 5 years with the different initial investment values. As you can see in cell B8, we used FE formula to calculate our balance after 5 years based on $2,000, which is entered in cell B2. We want to create a one variable data table and replace the initial investment value, which is $2,000, with different numbers ranging from $1,000 to $6,000, and calculate the balance for all the new initial investment values. As the first step, we should enter the variable values either in one column or across one row. In this example, we're going to create a column-oriented data table. Therefore, we type 1000 to 6000 from D3 to D8 and left one blank column to the right for the outcomes. Now we should enter the cell name that contains the formula to calculate the balance. We should enter the name of this cell in the cell that is one row above and one cell to the right of the variable values. Therefore, in cell E2, type B8. Then select the data table range, including the formula, variable values, and empty cells, and go to the Data tab, click the What If Analysis button, and click Data Table. Since our investment values are typed in a column, in the Data Table dialog window, click in the Column Input Cell box and type B3 that contains the initial investment value. This means that you want to replace the value of cell B3 with the values that are entered in the first column of your data table. I mean 1000 to 6000. By clicking OK, Excel immediately populates the empty cells with outcomes corresponding to the variable values. Now you can take a quick look at your one variable data table and see the possible balances based on different initial investment amounts. In the previous example, I showed you how to set up a column-oriented data table. But if you prefer a horizontal layout, you should type the variable values in a row, leaving at least one empty cell to the left for the formula and one empty row below the variables for the results. Based on the previous example, we entered the variable values in cell F3 to J3, and we entered the formula in the cell that is one column to the left of your first variable value, that is cell E4. Now we should create the data table, but this time we enter the input value into the row input cell. In this example, we will create a more complex one variable data table. We want to calculate different factors such as monthly repayment, total to repay loan, and total interest paid based on different interest rates. In fact, we want to calculate the values of cells B12, B13, and B14 based on different variables for cell B4. Since we want to calculate monthly repayment, total to repay loan, and total interest paid, enter equal B12 in cell E3 for monthly repayment, equal B13 in cell F3 for total to repay loan, and equal B14 in cell G3 for total interest paid. Then select the data table, go to the Data tab, and open Data Table. In the column input cell, type B4, which is the interest rate cell, and click OK. As you can see here, we created a data table with 4 columns. They show different monthly payment, different total to repay the loan, and different total interest paid based on different interest rates. The demo in the next slide provides another example for data table.
So I have this basic spreadsheet that I'm working with. It's just a profit model, and up here is my data entry area: unit price, unit cost, fixed cost, and the demand can simply be entered. Down below is mostly calculations. The unit price gets pulled from up above. The quantity sold gets pulled based on a min statement, and it's the minimum of either the demand or down here the quantity produced. So those two numbers would need to be entered. The revenue is a simple calculation of quantity times price. The variable costs are the units produced times the unit cost, and then the fixed cost, and we end up with a simple profit calculation of the revenue minus both costs. So it's a working spreadsheet. We could do a little what-if analysis by simply entering numbers up here and just say, well, what if our demand was 25,000? Then our profit would be negative 360,000. So we have some different ways that we can kind of explore what's going to happen to our profit under different scenarios. But keep in mind that that min statement's in there, so it's always going to be calculating a min of the quantity produced and the demand. So we've got a cap on the capacity that we're able to handle. But rather than just hard typing the numbers in, Excel also has the one-way data table function, and so that's what I want to demonstrate here. And so I'm going to move over here on the right where there's some space for us to create this new data table, and I'm going to tell it that I want to calculate profit. So I'm just going to put equals C22, so that'll draw in my profit calculation. And I'm going to move down and over one, and I'm going to put in different levels of demand. So I'm going to put in 10,000, 15,000, 20,000, and then I'm going to actually just use the replicate function in Excel to get us down to, let's say, 60,000. There we go. Now, this is where our data table is going to go. And so I'm going to go to the Data tab, choose What If Analysis, and then Data Table. And it asks me, I'm going to actually build this as a column, so I'm going to put it over here. And it's asking me actually which value I'm going to substitute into my table over here. And that's going to be demand. So I'm going to put B8 in there. So what Excel will do is it'll take each of these values, it'll substitute them into the demand cell and use that to recalculate profit. And there it is. So our profit at a demand, I'm going to put some titles in here, demand. Go ahead and center that up. And this is the profit calculation. So our demand is 10,000, then our profit's going to be negative 960,000. At 15,000, negative, 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 right down the line. At 35,000, we finally move to a positive profit. But then it hits 240,000 and stays there, which is okay because right now I'm capped at a production quantity of 40,000. So I really never sell more than 40,000. So the data table is here. It allows me to test all these values at once. I can format it just like I do any other table. I can set it up with the dollar signs and everything so it looks correct. And this all should have commas, so we can set up a really nice table and get rid of those decimal places. So Microsoft Excel has allowed us to create a table of values, and this can be much longer, as many as I want to test. And I tell it to use this cell's formula, and it substitutes in. So it's a great way to do what-if analysis.
A two-variable data table shows how various combination of two sets of variable values affect the formula result. In other words, it shows how changing two input values of the same formula changes the output. For instance, you can compare how different interest rates and different down payments impact the monthly car payment. Please consider that in contrast with one variable data table, you can focus on only one result instead of multiple results. For example, you should choose how the variables affect either monthly payment, total amount to repay the loan, or total interest paid. In this example, we want to use two variable data table to calculate the balance based on different initial investment values and different number of years. As the first step, create a table and enter different initial investment values in one column and different number of years in one row. Then enter balance cell in the intersection of the first row and the first column of the table. In this step, select the entire table range and go to the what if analysis and click data table. In the row input cell box, enter the reference to the input cell for the variable values in the row. In this example, it's B6 that contains the years. In the column input cell box, we should enter the reference to the input cell for the variable value in the column. So type B3 that contains the initial investment value. As you can see here, Excel calculated the balance based on different initial investment and different number of years. Here we have another example for two variable data table. We want to test how the monthly repayments vary with changing interest rate and down payment values. Similar to the first example, we should create a table first and type different interest rates in one column and different down payments in a row. Since we want to calculate monthly repayment based on different down payments and interest rates, You should add monthly payment cell in the intersection of the first row and the first column of the table. Now go to the Data tab and click Data Table. As the row input cell, enter the down payment cell, which is B3, and as the column input, enter the interest rate cell, which is B4. As you can see here, Excel calculated monthly repayments based on different down payments and interest rates. Watch the demo in the next slide. The demo shows an example that compares one variable with two variable data table.
I've got in column A interest rate, months, finance amount. So this could either be a car note or a house note. If it was a house note, 30 years times 12 is 360. If you want to go 15 years, that would be 180, 15 times 12. And then whatever your finance amount is for your house. So this could be a new house note, a refi, or it could be a car, new or used, it doesn't matter. Let me go back and leave it as a car to start off with. Your payment for 5%, 60 years, which is 5 years, 60 months, 24,000 is the PMT function. What interest rate are you looking for? B1, and you need to divide that by 12 because you pay your note monthly, comma, number of payments or number of periods, that's the number 60, B2, comma, PV is present value. How much money do you have to borrow today to get that car? This is after a down payment. It's after a trade-in. The other two arguments, F, V, and type are not required. Press enter. There is your answer. It always shows as a negative number, so I'm going to double click and make it negative B3. So now it's positive. So your total payments is simply your monthly payment, and we're going to multiply that times the number of periods you need to pay it. 27,175. So therefore the interest paid is B6 minus how much you financed today for it, which is 24,000. 3,175. Remember the keyboard shortcut, Control and the key that's to the left of number 1 on your keyboard. It will show your formulas instead of your answer. You just toggle back and forth. So these three right here, those are input cells. Those are just numbers I typed. These three down here are dependent cells because they're dependent on the input cells. So now let's do the data tables. I'm going to do 2 of them. The first one is called a one input data table. What I'm trying to figure out is if I have a different interest rate, what's my car note? So I'm going to start off at 0.275 and then 0.3, and let's autofill those down. And I'm going to stop at 7%. 6% works. Home tab, let's make them percentages and increase the decimal. There's my interest rates. In F1, I've got to do this formula, a 3D reference equals, and it must be a dependent cell. I'm trying to figure out what's my payment going to be at those interest rates, so it's equals B5. I'm going to hide that in just 1 second. Highlight E1 to F15, data tab at the top, what if analysis, data table. I've got 2 options, column and row. Notice they both say input, which means it's going to be one of these numbers over here. I'm running down column E with those percentages, 2.753. So it's going to be column input B1. Watch what happens when I click OK. That is my monthly car note for those different interest rates. Let's just make them look a little better. Home tab. It's up to you. Comma. If you don't like comma, go make it currency. Lose the decimals. If you want to hide that number right there, that's that 3D reference. Control 1, custom, On your keyboard, 1 semicolon, 2, 3. Just trust me, it's 3. Don't do 1, don't do 2, do 3. Click OK. That number, that 3D reference is still there. I can see in the formula bar, but that is hidden. What's nice about this is I want to know how much interest I'm going to pay at these different interest rates. So let's just do equals B7. Should be increasing, and it does. If I don't know the total payment, equals B6. So that is called a one input data table. Now let's do a two input. If I do a two input, I usually don't do the one input. I'm just showing you can do a one if you want. Here's a 2. Let's do, I'm over in J2. So now it's not just the interest rates, it's the interest rates and the finance amount. I'm going to put the interest rates across the top. Highlight both of those, autofill. 6% works. Format them. That is going to be empty. I'm going to come right here. Actually, that's where I'm going to start. So 1 down, 1 to the left. I'm going to do 22,000 because maybe I don't need a $24,000 car. Maybe I found something for 22,000. Now let's do 22,500. I like both of those. Crosshairs. And let's take it out to 26,000. I'm going to click in cell I2 equals. I still have to do the 3D reference. So I'm still doing a data table, but I'm not doing a 1 input. I'm going to do a 2. That's why I got interest rates and the finance amount. I want to know what the payment is. Highlight. Perfect. Data. What if analysis. Data table. So now I'm going to use both of these boxes. Going across the row right here are my interest rates, and notice again it says the word input. That's why I put this over here to help you just learn how to do this. B1, column input, running down the column I, are the finance amounts. So this is a 2 input data table. When I hit OK, perfect. Those are my monthly payments at those interest rates. There I go. What's really nice about a data table is you cannot delete just one specific cell. You'll get an error message. I click over here, hit delete, can't do it. And again, if I wanted to hide that, it would be Control 1, what's my bad, Control 1, Custom, 1, 2, 3. Good to go.
The Scenario Manager is an interesting feature that lets you swap multiple sets of data in a worksheet and even compare them side by side. This technique can help you decide between multiple courses of action or what the implications are among several possibilities. For example, let's say we are a concert promoter and we want to decide what venue to use based on total costs and ticket price of each venue to increase the final profit. Here you can see the table that is created for calculating costs and revenue of the concert. Let me explain the cells for you. All the costs are entered in cell B6 to B12. B13 calculates total costs by adding the values of B6 to B12. B19 calculates ticket sales revenue by multiplying the number of seats by ticket price, which means B4 by B17. B20 calculates merchandising revenue by multiplying $5 by the number of seats in cell B4. We assumed each person will spend an average of $5. B21 calculates food and beverages revenue by multiplying $15 by the number of seats. We assume that each person will spend an average of $15 for food and beverage. And B22 calculates the total revenue by adding the revenues from B19 to B21. And finally, B24 calculates the profit or loss by subtracting total cost from total revenue. It means B22 minus B13. As the first step, open the Scenario Manager. To do this, go to the Data tab, open What If Analysis, and click Scenario Manager. Now we should create the first scenario. Therefore, in the dialog box, click Add. Then enter a name for the scenario, which is the venue name, and enter the cells that you want to change their values and calculate the revenue based on their new values. Since we want to calculate the revenue based on the cost of different venues and their ticket prices, we enter the cells that contain costs and the cell that contains the ticket price. So enter B4, B6 to B12, and B17. By clicking OK, the scenario dialog box shows a list of all the cells in the scenario and their current values. Enter the new values for the first scenario and click Add to create another scenario. Add all the scenarios and click OK to return to the main Scenario Manager screen. In order to view all the scenarios at once, click the Summary button. As the last step, we should identify the cell or cells that will be affected based on the defined scenarios. Since we want to see different values of the profit cell based on the defined scenarios, enter B24. By clicking OK, a new sheet called Scenario Summary is created and shows the scenario results. Here you can see different results for the profit cell based on different costs and ticket prices. In order to have a better understanding of Scenario Manager, in this example we want to create some scenarios for the car loan worksheet that we use to explain data table. In this example, we want to calculate amount of loan, periodic rate, number of payments, monthly payment, total to repay loan, and total interest paid based on different scenarios for down payment, APR, and number of years. As the first step, open the Scenario Manager by going to the Data tab and clicking Scenario Manager from What If Analysis. In order to add the first scenario, click Add and give a title to the scenario, then type the cells that you're going to change in the scenario. Based on the example, we're going to change the value of down payment, interest rate, and the number of years for the loan. So type B3 to B5 here. In the next step, we should enter the desired values for down payment, interest rate, and the number of years. For the first scenario, we enter $7,500 for the down payment, 4% for APR, which is the interest rate, and 5 for the number of years. After creating all the scenarios, select the desired scenario and click Show to see the result of that specific scenario. Or if you want to see the result of all the scenarios at the same time, click the Summary button. Since we want to see different values for amount of loan, periodic rate, number of payments, monthly payment, total to repay the loan, and total interest paid, type their cell references and click OK. As you can see in this report, amount of loan, periodic rate, number of payments, monthly payment, total to repay loan, and total interest paid are calculated based on different down payments, APRs, and number of years. Watch Scenario Manager demo in the next slide.
Here we have a set of data. This is a student set of data. There are 20 grades, and we have exams 1, 2, and 3 in the first 3 columns, and we have exam labs and homework, and then we have a column F that is overall average. Overall average, let's click in that cell. You can see the formula for overall average is 25% of the grade is from exam 1, 0.25 or 25% of the grade is B2, exam 2, 25% of the grade exam 3 or C3, 15% of the grade is from Excel labs, and 10% of the grade comes from the homework. And that's how the F column is calculated. The F column is overall average, and that's how that's calculated. Okay, let's use the what if analysis tool to evaluate the different scenarios for exam 3. Here we have exam 3, and I want to know for different grades, let's say I get a 60 on the exam or 65 on the exam, how would that change my overall average? So let's do a what if analysis by clicking on the scenario manager, and let's add scenarios. It says here no scenarios are defined. Let's add some scenarios. I'm going to add scenario 1. I'm going to use exam grade, and I'm going to try a 50. So let's click OK, and enter values for each of the changing cells, and I would say 60. That would be the changing cell. Let's try another scenario. Let's call this exam grade 65. We say OK, and that would be for 65. And let's add another scenario, exam grade 70. And we say OK, and that would be 70. And if I click OK, then you can see the different scenarios here, and I can try each of these at a time. Let's say I want to see what would happen if I got a 70 on the exam. I click Show, and you can see the overall average change to a 76.5. What if I did really bad and I got a 50 on the exam? Keep an eye on this overall average. If I say Show, my average is going to go down to a 74 if I get a 60 on the exam. So we set up different scenarios here, and we can try each of those. If I get a 65, and it shows me what my average, how my average would change based on each of these scenarios.
The last feature that we want to discuss is forecasting sheet. Forecasting is a special technique of making predictions for the future by using historical data as inputs and analyzing trends. This method is commonly used to make educated guesses on cash flows, plan budgets, anticipate future expenses or sales, and so on. Excel Forecast Sheet feature can help you to turn a worksheet containing historical financial data into a remarkable visual forecast worksheet. Before using Forecast Sheet, you should arrange your data into your worksheet. Your worksheet needs to have 2 columns, including time columns such as date or time values that are entered sequentially at a regular interval, and a column with numerical values that will be used to predict the future. In this example, we will try to forecast sales for the next few years based on the existing historical data. As the first step, select both columns of your data and go to the Data tab and click the Forecast Sheet button. Then Create Forecast Worksheet window opens and asks you to choose the graph type and end date for forecasting. If you would like to change any of the default options of your forecast, click Options in the lower left part of the forecast window. By clicking Options, you can see different items that can be used to customize the forecast. The first one is Forecast Start. This option is used to specify the start date for forecasting. Confidence interval is a range in which the predictions are expected to fall and can help you to understand the forecast accuracy. Seasonality is the length of the seasonal pattern in which regular and predictable data fluctuations occur. For example, in a yearly pattern where each data point represents a month, the seasonality is 12. Timeline range is the range used for timeline series, and value range is the range used for value series. Fill missing points controls how missing points are handled. By default, Excel uses the interpolation approach where the missing points are filled based on the weighted average of neighboring points. And finally, duplicate aggregates determines how multiple values with the same timestamps are calculated. After selecting the desired options, including forecast date and chart type, click the Create button. Excel creates a new sheet containing a table with your original and predicted values, as well as a chart that visually represents this data. Watch forecast sheet demo in the next slide.
To create a forecast sheet, you must have a series of date or time entries for the timeline, and also corresponding values for those time or date entries. From these existing date or time values, Excel can then project future trends and the associated values for future dates. Before you create a forecast sheet, ensure your timeline values have consistent intervals between its data points. For example, you could have consistent daily, monthly, or yearly values for which to create a forecast. The timeline can have up to 30% of its data points missing or have duplicate timestamps on different values and still produce an accurate forecast. However, you may want to summarize and organize the data before creating the forecast sheet to produce the most accurate forecast. To create the forecast sheet, either select both data series to forecast or click into a cell within one of the data series to forecast. Then click the Forecast Sheet button in the Forecast button group on the Data tab of the ribbon to open the Create Forecast Worksheet dialog box. Choose either the Create a Line Chart or the Create a Column Chart button in the upper right corner of the dialog box to display the forecast as either a line chart or column chart. Below the chart, use the Forecast End drop-downs or spinner box to set the end date time or ending value and how far out to project the forecast. To set additional advanced forecast options, click the Options arrow or link at the bottom of the dialog box to expand that section if needed. You can select a different forecast start date by using the Forecast Start drop-downs or spinner box to set the start date time or starting value for the forecast. If you pick a date before the end of the historical data, only data prior to the start date is used in the forecast. For seasonal data, Excel recommends starting the forecast before the last historical point. You can check or uncheck the Confidence Interval checkbox to show or hide the confidence interval in the forecast. If shown, the default confidence level of 95% can be changed by using the adjacent spinner box or by typing a new percentage to use into the box. To choose how to determine seasonal intervals, select an option button under Seasonality. The default option is Detect Automatically. To manually set seasonality intervals, select the Set Manually option button and enter the seasonal value into the adjacent field. For example, in a yearly sales cycle where each data point plotted represents 1 month, the seasonality value would be 12. When manually setting seasonality, avoid using a value less than 2 to prevent the forecast from reverting to a linear trend. In the Timeline Range field, you should see the range of timeline values. These are the time values that correspond to the data values shown in the Values Range field. The Values Range field contains the data values for the timeline values. You can use the Fill Missing Points Using drop-down to select zeros if you want to fill in missing data points with zeros. The default value of interpolation uses the weighted average of neighboring points to fill in the value of missing points. If your data series contains multiple values with the same date-time stamp, Excel will average the values with the same date-time stamp. To use a different function, such as median for example, select the function to use from the Aggregate Duplicates Using dropdown. To include forecast statistics on a new sheet, check the Include Forecast Statistics checkbox. This includes a table of statistics generated by the forecast.ets.stat function and includes measures such as the smoothing coefficients and error metrics. When you are ready to create the forecast sheet, click the Create button in the lower right corner to add the new forecast worksheet to your workbook. This sheet contains the selected data series, the forecasted values, and the upper and lower confidence bounds, if selected, in a table on the sheet. These values appear within a chart on the same sheet. You can edit the table's values or formulas to change the values in the forecast chart if desired.
We're done for the Excel part of the course. I hope the lectures could give you an in-depth knowledge of Excel. If you have any question about the assignment, post it on the course forum. And good luck with your assignment.